In this module, we're going to take a look at the answers to midterm exam number 1 for Econ 3100 section 60. And this is for summer of 2015. This section was taught at the Murray campus. So let's go ahead and take a look at this. As we go through this module, we're going to have 3 different segments. Segment 1, we'll look at part 1 of the exam. You might recall that in part 1, you were responsible to provide answers for question 1 or 2. I've gone ahead and provided answers for question 1 and 2, of course. That way you can see how this worked out regardless of which question you answered. In segment 2, we'll take a look at part 2 of the exam, and we're going to be looking at questions 3 and 4 because you were responsible to answer question 3 or 4. And then in part 3, or segment 3 of this module, we'll take a look at part 3 of the exam with question number 5, and everyone was responsible to answer question number 5. So let's begin with this. So first of all, problems 1 and 2, this is part 1. So in this, we're looking at BJSG Ribs in Mankato, Minnesota. We identify a labor-demand relation here of 68 minus 2W. That's important to us. I indicate that this is a profit-maximizing firm, competitive labor market, and numerous employers. That's probably important. I indicate they all have the same labor relation with these firms, so that tells you we don't have to really think about this. Plus, there's no labor supply requirement within the table that you're about to look at. And I tell you that the price of ribs is $1.50 per unit. Well, if this is a competitive market, then the price of ribs is $1.50 per unit, whether it's 1 pound of ribs, 1 unit of ribs, or 1,000. So we can just use that as a constant number. That would be the output price for a good in a competitive goods market. Okay, so in this case, I've given you a column with some wages. I've given you a column with some quantity of output, and that becomes important. And I ask you to give me some various variables here: labor demand, marginal product of labor, price of the output good, and marginal revenue product of labor. So labor demand, of course, all we're doing is we're taking the wage and substituting it into the labor demand equation. So in this case, 68 minus 2 times W, or 68 minus 14, is 54. And then we're taking for the next row the wage of 8, substituting it into the same equation, and we get 52. And we do this down all the way through. So you should have started at 54, decremented by 2 labor units per row, and then end up at 32. And that was the labor demand column. To get to marginal product of labor, recall the marginal product of labor is change in Q divided by change in L. So when we have Q changing, Q was given to you, and so we now know that if 7 was the wage, 54 was the labor, Q is 660, and then when 8 is the wage, 52 is the labor, Q is 654, so 660 to 654 is a change of 6 divided by a change of 2, marginal product of labor is 3. And of course that's how we work this all the way down. Then we've given you the price of the output good at 1.5, so ribs are 1.5, and since it's a competitive market, we use the same 1.5 all the way down. And then finally, the marginal revenue product of labor, which you'll recall is marginal revenue product of labor is marginal product of labor times the price. So 3 times 1.5 is 4.5. 4 times 1.5 is 6. 13 times 1.5 is 19.5. So this is the way that this table should have looked. So we go to the next question. Then I'm asking you to tell me, based upon what you know about profit maximization in a competitive labor market, how many workers would the firm employ and at what wage would they be paid? So what rule are we going to look at here? Well, profit maximization in the labor market, we can easily see that at MRP of L when that equals ME of L. We know that's the general condition. But we know this was a competitive labor market. And in a competitive labor market, marginal expense of labor is equal to the wage. And that then suggests to us the marginal revenue product of labor is equal to the wage. Well, if I go back and look at my table, I've got wage and I've got marginal revenue product of labor. So literally all one needs to do is scan down these 2 columns at either end, and when we get to the point where the wage is equal to marginal revenue product of labor, in this case 15 and 15, then we know that we're going to hire 38 workers. So the answer was 38 workers at a wage of $15. We then go ahead and ask a question about elasticity. I want to know about the wage elasticity of demand as wages rise from 12 to 15 using the simple formula. And I ask you to go ahead and give me the elasticity, and calculate that, and tell me the basic type of elasticity. Well, you've seen me set this up before. I set it up with a W1, W2, L1, L2, because we know that the simple formula, which starts from a very simplistic, it is percent change in labor divided by percent change in wage, and we know that the simple formula is going to be L2 minus L1 divided by L1, which is a percent change formula essentially, divided by W2 minus W1 divided by W1. Now, to perfectly make each of these percent change formulas, we would multiply them by 100. We typically don't think about that, because if we're multiplying both the numerator and the denominator by 100, then that falls out. So we don't have to think about that. So what does that equal in this case? Well, we've got L1, L2, W1, W2. So how did I get these? Well, W1 came from the starting point of labor. W2 came to the ending point, starting point of wage. The ending point of wage. So that's W1 and W2. To find L1, I simply put W1 into the labor demand equation. Recall that it was 68 minus 2W. So I put 12 into the labor demand equation, and it returns 44. I put 15 into the labor demand equation. 68 minus 2 times 15, or 68 minus 30, is 38. So that gives me my L1 and my L2. And then I just go ahead and calculate 38 minus 44 divided by 44, 15 minus 12 divided by 12, keeping in mind that we have in our numerator the percent change in labor, and the denominator the percent change in wage. Then I go ahead and just continue to move this forward. This ends up being negative 6 divided by 44 divided by 3 divided by 12. At the place where I see some of you begin to have a little bit of difficulty or get into some small inaccuracies is if you took this value, negative 6 divided by 44, and went ahead and converted it to a decimal equivalent, that is 0.13636. When we carry it to 5 decimal points, it changes as you carry it beyond that, of course. I tend not to do that, because if I convert to decimals at this point, now I have, based upon what rounding rule I've used, I carry a slight rounding inaccuracy forward to the next terms, forward to the next term, forward to the value. I tend not to make my conversion to decimals until I get to the very end. And you might recall from the video modules on this that I also prefer, and rather than to do this complex division of fractions, I go ahead and invert the denominator. So 3 over 12 becomes 12 over 3, and I can multiply them so that I have negative 6 times 12, which is negative 72, and then 44 times 3, which is 132. And now I go ahead and take this term, negative 7 times, or negative 72 times 1 divided by 132, and that I'm going to go ahead and convert to a decimal equivalent and round it to 2 decimal points. So this was negative 0.55, which we should see this as inelastic. Inelastic. So in this case, we had a fairly simple calculation, and we found an inelasticity. So let's go ahead and look a little bit further then at question number 2. Question number 2, we give you a story about John. John's a college graduate. He's a mid-level executive. He's got years of experience. He's getting a wage of $55 per hour, which $55 per hour, if he works 40 hours a week and 52 weeks a year, is $114,400. So this is a fairly skillful guy. This is not a low-skilled employee. Maybe isn't even a moderately skilled employee at $114,000 a year. I think I would say that is a highly skilled employee. John has an investment providing him with $40 a day in personal income. That might also be thought of as an endowment, a $40 a day endowment. John's got a daily budget requirement of $562.50 a day, which if he's got a $40 endowment, that means from working, he needs to come up with $522.50 a day. Okay? And his supervisory position doesn't allow him to receive any overtime. That's important to us. And then John's employer allows him to work as many hours as he wants and pays him for working all those hours. So we come up to the first question, and that is, given what you know about John, what's his labor demand elasticity going to look like? And we're going to analyze this and be sure to talk about the type of elasticity and kind of interpret it with respect to labor demand. So I'm suggesting here in my answer that at $55 an hour, college graduate, years of experience, John's very minimally substitutable, and he's probably got a very low elasticity. I would think that to be true. At that wage, at that high skill level, probably very minimally substitutable by another type of labor. So it's going to be relatively inelastic, which simply means that any percent change in wage would be met by a proportionally lower percent change in labor, such that we're going to have a denominator that's smaller than a numerator that is smaller than the denominator, and it's going to be less than 1. Okay, so then I said, okay, fine, assume John is a participant in a competitive labor market and that the output price of his firm's product is $1,200. What can you tell me about his marginal productivity? Well, we have to put these things in perspective. If I'm saying his weekly marginal productivity, then I'm going to have to deal with a weekly income so that I can get the right value here. And I don't know the quantity changes. I do know the price of the output. And I remember that to get to marginal productivity, I might have to think about this issue of output and weekly income and maybe even wage here. So what are we really looking at? Well, what am I thinking about? I'm thinking that I'm going to think about marginal revenue product of labor. And the marginal revenue product of labor, which is simply going to be his weekly wage, in this case, is going to be equal to the marginal product of labor times the price of the output good. Well, I think I have two of these three variables. I know his weekly wage. If he is needing to earn $522 a day, he does that 522.5 for 5 days. That's 2,612. So 2612.50. And that equals the marginal product of labor times this $1,200 output price. Okay, so now all I have to do to isolate that marginal product of labor is I can go ahead and take and divide the 2612.50 by 1,200, and it's going to give me a value of 2.18, which is the marginal product of labor in this case, so 2.18. Then I go further on this. I ask you to give me a properly labeled and appropriately articulated labor-leisure or income-leisure trade-off model representing his daily labor-leisure decision. And be sure to indicate some representation of John's tastes and preferences. So let's think about how we put this together. The labor-leisure trade-off model on the y-axis has some income. Not necessarily just the wage, because there might be more involved here than his wages. And in this case, we know he has a $40 a day endowment. That's not a wage, but it certainly is part of his income. And then on the x-axis, we look at leisure and labor. And we suppose that in a 24-hour day, that there is either 16 hours available for leisure, which also means there's 16 hours available for labor. But we're looking at this at leisure as the primary driver of the x-axis, so we can go from 0 to 16 hours of leisure, which means at 16 hours of leisure we have 0 hours for labor if there's only 16 hours available to us in the day. We suppose there's an 8-hour regenerative period for sleep and such. So if we have 16 hours of leisure, we have 0 hours of labor, or if we have 0 hours of leisure, we have 16 hours of labor. So this gives us our x and our y structure. I've gone ahead and said, okay, with a $40 endowment, so at the $40 amount, John doesn't need to have any labor. He still has all 16 hours of his leisure, and he gets his $40. So I've got a solid line going straight up here to the $40 mark. And then I can go ahead and think about what's the slope of this budget curve. Well, the slope of the budget curve is his wage. It's the negative of his wage, actually. So negative 55. So at here, at 0 hours of labor, 16 hours of leisure, there's $0 contributed by the wage, so we're still at a $40 amount. Over here, at 16 hours of labor, 0 hours of leisure, we can think of this as $55 times 16 hours, which is going to take us up to the 880 mark. I've actually incorrectly specified this here. Please excuse me. This should have been 920 because it's 880 above the 40. So if I've got $55 an hour for 16 hours, 55 times 16 is 880 plus my original 40, so it takes me to $920. So I can go at 16 hours of labor for John, $40 endowment, $880 of wage. That takes the top of the budget curve for the day is $920. If he put all of it into labor, or if he puts all of it into leisure, he's still at $40. Well, we know that his budget requirement is $562.50, and we know that if we've gone ahead and said that $40 of that has come from his endowment, that there's $522.50 that had to have come from his labor. Well, divide that by his wage, and we see that there is a 9.5 hours of daily labor. So there's 9.5 hours of labor. Add that to 6.5 hours of leisure to get the 16 total, and we know then that that's where he will reside on his budget curve. And that budget curve is, or his $560.50 requirement is informed by his preferences and his tastes, which sound to me an awful lot like an indifference curve. So it is at this point on the budget curve where his indifference curve will be tangent to the budget curve. And that's how we've answered number 2.